Hello everyone, my name is Shivers and I want to showcase a project that I've been doing. So, back when DeepSeek came out earlier this year, Twitter went crazy trying to replicate what DeepSeek has been doing, and then a lot of material came out. One of those materials is a notebook by Mr. Will Brown, where he fine-tuned qwen 2.5p on gRPO and made a reasoner model. Originally, it's just a instruct fine-tuned model. The original score, let me check. Qwen 2.5 instruct. What is the score? GSM 8K score. Okay. GSM. No, this is a quantized version. GSM 8K score. I'm gonna edit this part out. Results GSM 8K. Okay, so I found the score. Originally it was 40.1. It scored 40.1 for the instruct model. Now, after fine tuning it with the dataset itself, like there's no leakage, right? Because he made it, there's no leakage. After fine tuning it on the training set, we are able to achieve a score of I'm sorry, give me a second. We're able to achieve a score of 46%, so we have a 6% increase in score, which is nice. Originally, in the original notebook, there is no evaluation code. I added the evaluation code myself. Yeah, and I also modified the code for downloading the model. This is I forget why I did not delete it. So this itself is not an interesting project. Like, you literally just add normal Python code to evaluate it. It's nothing special. It's just some it's just some regex thing. You just somehow extract the answer out of the thing. This is nothing novel. Whatever, what I'm trying to do is that, okay, now we can do full fine tuning and get 6% of performance increase. Now, if we use LoRa fine tuning instead, what will happen, right? So, currently I'm training for rank 8. This is literally the first experiment that I am doing. So we will use a LoRa adapter. We will vary between different ranks. I plan to test from rank 1 to rank 64. Rank 128 is too big because this model is not big. It's small. I talked to Claude, and apparently 2 times the rank is good because the actual learning rate is LoRa alpha divided by rank, so this keeps it consistent, making it vary with the rank. And then we load the model. We set up the training arcs as before. We changed the gradient accumulation steps from 4 to 16 because otherwise it would not. The training would not start, and the error message said that I think gradient accumulation step must divide num generations without remainder, right? I think something in the lines of that. It's too long. I'm not gonna type that. I mean, no one's gonna read it anyways, right? And then we also set vLLM equals false because apparently perfect model is not supported by vLLM. So we're gonna use vLLM equals false. As a result, the training is very, very slow. We have been training for 7 hours already. Uh, and we're training with less parameters than the original, like, full fine tuning training because we're training a LoRa. We're training a LoRa adapter. We're not training full fine tuning the whole model. Uh, yeah, it has been 1.5k checkpoints. In the original notebook, I think the training ended at checkpoint 1,850 something, and then it ended, right? So, but I wouldn't know when it will end, right? But I have plenty of compute credits. I have 240 compute credits, and if I run out, I'm just gonna buy more. So yeah, here it is. The project itself is simple. I think I just replaced the full fine tuning with the LoRa fine tuning, and then I'm trying different ranks for the LoRa fine tuning. Yeah, it is this simple, and someone else would have done it already, but I still want to do it. So yeah, this is my project. As we can see, it's still training. The first experiment. I'm planning to do multiple experiments. I'm trying to see what the let's say if this task of performing reasoning would saturate the model. So let's say if we go from rank 8 to rank 16 to rank 32, and we already see performance plateauing from rank 16 to rank 32, it means that we don't really need to do fine tuning for this kind of thing. We just do we can just do like LoRa rank 16, right? And then just call it a day. We don't need to do full fine tuning. Obviously, this might not be true. It might end up that we go from 8 to 16, 32, 64, and we end up with the same. We end up with the same performance, or even worse than the original baseline. I think this can happen as well, but I don't know. We are gonna see. And then one more thing that came to my mind when I was discussing this with one of my friends is that okay, I can train LoRa for a quote unquote reasoning LoRa for a model, right? If I combine it with, let's say, a role playing model, what would happen? I am really interested in knowing that, right? I really want to know how good it would be, because now we see there are a lot of like Coco vanilla reasoning models, and obviously we know the biggest reasoning models are like Claude 3.7, qwen 3. They can do every task, right? But let's say for some smaller models, right? Let's say for some role playing model, I don't think we have seen any reasoning role playing models, right? And reasoning role playing models. Yep, 6 months ago. Yep, this is a bad case where a role playing model sucks. Using 5. Role playing performance, suitable, blah blah. This might be the case, but I can probably like train a LoRa for a model, and then maybe there's a LoRa for role playing purposes, and I'm pretty sure there's ways where you can like use multiple LoRas at the same time. You can either merge the LoRas, or you can I think they can do some weird routing thing, right? and then just use multiple LoRa's at the same time, and then maybe we can have a guy that can actually think, like a reasoning a role playing model that can actually think or reason or do long reasoning, right? Sorry for stuttering. I have a really bad problem with that. Yeah, that's basically it. I'm still waiting for this experiment to end. It has been 8 hours. I'm going to do at least 3 more experiments with rank 16, 32, and 64. Once that's done, I will post again and tell you guys, or maybe just tell myself what the results are. So yeah, catch you guys later.